And with that, we'll turn it over to Madison.
Perfect. Thank you, too. Hopefully you can hear me. OK, thumbs up if you can. Great, thank you. Yeah, so unfortunately, I lied. At the time that I submitted this talk, we were managing over 600 million openly licensed media records, and that number has now breached 700 million. And that has caused some problems for us, which I will talk about in the presentation. But like these two lovely MCs said, my name is Madison Swain-Bowden. My pronouns are she, her, and I am a data engineer at Automatic. I'm going to talk about the team that manages Openverse. So that's the project that I work on. I'm a sponsored maintainer of Openverse. It's what I'm going to be talking about today. These are the other sponsored maintainers. There are 8 of us across 6 countries who speak over 7 languages. We are part of an Automatic effort, an effort that was pushed forward by Automatic called 5 for the Future, which urges tech companies to put 5% of their efforts, profits, workforce towards open source to help empower the future. There's some alumni here from Creative Commons. If any of you are familiar with Creative Commons, they came forward to continue working on this project, which I'll talk about the history of in a little bit. I'm listed as the only data wrangler on this slide, but that's just an official title only. All of us sort of do all of the things. We have one designer, and then the rest of us are kind of everything. We have front-end engineers, we have back-end engineers. I do infrastructure work, I do API work, on top of all the data stuff. 8 people is not a lot to be running a whole search engine, so we kind of have to do a little bit of everything. A bit about myself. I'm a data engineer by trade and have been since 2018. I live in Seattle here with my wife and pets. Had to drive across the lake, though, to get here today. I live in North Seattle. And previously, I've worked as a data engineer at the Allen Institute for Cell Science and UCLA, which runs speedtest.net, if any of you are familiar. So today, I'm going to talk about what Openverse is, what's this project. And in order to do that, I'm going to give some context behind licensing and like what use cases for licensing are. A lot of us are familiar with software licenses, but Creative Commons, which I'll be describing, provides licenses for all sorts of things. So what is Openverse? If you go to openverse.org, the section on the right is what you'll see. Our tagline is Openverse is a search engine for openly licensed media. Now I say that, and people start processing that sentence, and they rarely get past search engine. So I'm going to go through each of these bits just to describe them a little bit more. It's a search engine. Many of us are familiar with search engines, right? They're used to find and locate things. Say, let's Openverse it. Openly licensed is a little bit more tricky. So the items that we index are licensed either primarily as public domain works or with Creative Commons licenses. And per Creative Commons, their licenses are tools that they provide everyone, from individual creators to large companies as well as institutions, with a simple and standardized way to grant legal permission to their creative works, which can then be copied, distributed, edited, remixed, and developed, all within the limits of copyright law. So that's a lot of legal terminology here. The purpose of these licenses, which I'll get into more in a little bit, is just to empower creators to have rights over the work that they create. And lastly, media. Right now we have images and audio, images comprising the vast bulk of the items that we index. But we also have goals to add different media types like 3D models, video, and text. So the point being, if you were to search bird, you're going to get pictures of birds. You're going to get albums that have the title bird in it, that sort of thing. Later down the line, it will be textbooks that have bird in them, etc. So Openverse started off out of Creative Commons as a project called CC Search in 2016. And this was an effort by Creative Commons, who developed these licenses as a way to showcase, here are all of the different kinds of media that people have licensed with Creative Commons licenses. In 2021, they announced that they could no longer maintain it. It was more expensive than they could handle as a nonprofit organization. And so at that point, Automatic offered to take it over. And since then, we have rebranded and turned it into Openverse. And so this is, like I said, this is what you'll see if you go to openverse.org. And I had mentioned earlier, if you make a simple search, like water falling, for instance, the results that come up are openly licensed pictures of waterfalls, of the house, the architecture design water falling, right? You have audio clips of water falling, songs that people have called water falling. And in this aggregated view, on the right-hand side, there are a number of filters. And those filters will let you select specific licenses. So I'll talk about those licenses in a bit. But that's sort of the power. Google has recently added in their image search a like Creative Commons license images filter on their search. But they have no distinction on which kind of license is served by, or which kind of license you're filtering down into. And these licenses can have implications on their use, which are important to know about. So if you filter down to images, too, on Openverse, then you have a bunch of other additional selectors for things like what kind of image it is, what the extension of the image is, aspect ratio. And similarly for audio, we have other filters for that as well, including the category of the audio, the extension, the duration of the audio, so that if you're looking for a smaller clip, you can filter by that as well. So Openverse is an aggregator, right? We don't host any of this media. We just provide a means of searching against all of the openly licensed media. Not all of the goal is all of the, right? But many different pieces of openly licensed media across the internet. And so right now I had mentioned we're primarily image and audio. We have some providers like Flickr and NASA. Flickr is by and large our biggest provider. They have the most images in our data set. But we also aggregate images and audio from things like museums, libraries, other openly licensed stock photo websites. And then we have some providers like Wikimedia Commons where we get both images and audio as well. So I'm going to talk about licensing next. Again, if there are any questions about any of this as I'm going through, please feel free to ask. I'm happy to answer that as we're going through. In order to talk about licensing, I want to take one step back and talk about the commons. This is the commons that Creative Commons refers to when as part of their name, right? And the commons is this notion of the cultural and natural resources that are accessible to all members of societies, or of a society. And described a different way, the Digital Library of the Commons talks about the commons as a general term for the shared resources in which each stakeholder has an equal interest. And so this sort of perspective about the commons as an entity or as something that folks can contribute to is what has driven Creative Commons to develop these licenses that enable their creators to have licenses that are part of the commons, that folks can contribute to the commons, but they can still retain some rights to as creators. Intention is to power them by allowing creators to share their work on the conditions of their choice while still retaining rights. And this all is done through the framework of copyright law. There's 8 different license types. I'm not going to go through them all, but the important thing to note is that there's just a variety of different license types depending on your use case. So if you're a creator and you want to license something a particular way, similar to how one might license software, right, with MIT or BSD or whatever license type might be necessary for or desired for your use case, you can also license creative works. So if you take a photo, if you record some audio, right, if you write a textbook, those can all be licensed with Creative Commons licenses that have certain attachments to them. So for instance, some licenses might dictate that you can share the adaptations, but they have to be shared under the same license type. And so I think that this has an allegory to some similar licenses in the software world. Or other licenses that say you can't use whatever is derived from this with commercial purposes. Almost all of the licenses, except for the bottom two, require you to attribute the creator if you end up using this, right? But then the last two are either public domain, public domain mark, or CC0, which is just a way to get as close to public domain legally as possible. And those say, I'm the creator, I'm ensuring that this work in perpetuity does not have any conditions to its use, but I'm acknowledging that as the creator and assigning this license to it. So the power, I mentioned this a little bit with Google, right? You can filter by these licenses, but again, if you're trying to find something for a commercial purpose, you might not be able to know from Google image search which license is going to actually allow, or what image is going to allow you to use that for a commercial purpose. So that's the power of Openverse, is being able to filter by these license types depending on your use case. And additionally, Openverse provides the attribution text necessary for an image or an audio record just as part of the image page. So if you find an image, you're like, this is perfect, this is great for my use case, you have the attribution text right there in 3 different forms, the rich text, HTML, and plain text as well. So we'll talk about some use cases here. Why might one want to use openly licensed media? Say you're writing a blog post and you want to add content to a blog post. This, incidentally, is a blog post about Openverse that somebody wrote, and they used an image that they also sourced from Openverse, or found on Openverse, rather, and we're giving attribution to the creator for that post. If any of you are familiar with WordPress, Automatic does a lot of work in the WordPress space. And recently, Openverse was integrated into the most recent version of WordPress. So if you have a site that's running WordPress, and you want to add media to that site, the Add Media screen also has an Openverse option. And so you can search for media in Openverse on your WordPress site just as you're writing a post or what have you. And then when you click to insert that media, the attribution will come along with it. So you don't have to necessarily take any extra time to add that attribution. You can acknowledge the creator of the content without any extra work on your behalf. Oh, and here's an example of that, right? We have the attribution text that's at the bottom. Another use case, you're starting a podcast, right? And you want some intro music for your podcast. You're not planning on making any money on this podcast. It's just something you want to do for fun. So you can use any one of these licenses to find music that can start at the beginning of your podcast. In another example here, perhaps we want to find a sound sample for a mixed song. So in that case, we might be restricted on what licenses we can use because some media is tagged with a license that does not allow you to remix it or adapt it or transform it. And so those are licenses we have to avoid. So that's all the introduction. Now I'm going to get very briefly into the tech stack, and then I'll get into the data stack after this. So Openverse is powered by a Next.js front end, which is running in ECS. So if you go and hit the web browser, openverse.org, that's what you're going to see. We also have a Django REST API that's also running on ECS. And so you can use the API directly if that's preferred for your use case. And that interacts with an Elasticsearch cluster and a Postgres database that backs it. Now the more interesting piece. So as I'm walking through this, this all comes with a bit of a caveat. We inherited most of this stack as the Openverse project from Creative Commons. And so there might be some things here that are kind of interesting or unique, and those are the result of just inheriting an open source project and then continuing to shepherd it into the future. So on the right here, we have the Postgres database and the Elasticsearch cluster that I mentioned before. Those service our API. But in addition to that, we have what we call our catalog database, which is also Postgres, and then a bespoke data refresh server that's running in Falcon. Both the catalog and the data refresh server are managed by Airflow, meaning that any interactions that are happening with them, Airflow is the one that's orchestrating them. So here are some differences between, you might be wondering, why do we have two Postgres databases? I certainly was when I first started on the project. On the left side, we have the catalog Postgres database, and then the right side is the API database. And the one on the left has far fewer indices than the one on the right. And the intention behind that is we are writing more heavily to the catalog directly, and we're writing to the API very infrequently, but we're reading from the API quite frequently and in service of requests, right? And so the API database is heavily write optimized, while the catalog database is more, the API is more read optimized, while the catalog is more write optimized. So in the grand scheme of things, right, if we put all of Openverse in a box, data goes in by way of, from the left-hand side of this diagram, by way of ingestion from provider APIs, which I'll talk about in a sec. And then it comes out of the Openverse ecosystem by way of API requests that are served to either some client that's interacting directly with our API or the front end. And if we zoom in on the left side, this is primarily how our data gets into the catalog. So we have these different providers. I had shown them at the very beginning, those image and audio providers. Those providers have APIs that we're able to interact with. So Flickr has an API. Another one is the WordPress photo directory. StockSnap is another provider. They have an API. Different like libraries and museums and other institutions have their own APIs. And so all of these have unique ways of serving different kinds of data. And so we have a series of provider API scripts that interact with the REST APIs, transform the data into something that's more uniform, and then inserts it into the catalog by way of writing to a TSV and then having that be pulled into the catalog database. Some of these happen, so like Flickr's API will let us query across a day, and it even has resolution down to like a couple of minutes, so we can query what were all the records that were updated, in this 5-minute time span. Whereas there are other APIs like StockSnap, and the WordPress photo directory as well, just provide their entire data set as a iterative, like a series of pages that you have to iterate through. So on some, we are reprocessing the entire data set on a weekly or monthly basis. And then on others, we're just gathering the most recent day's worth of data and adding that into our catalog database. We're also exploring some ways to do bulk ingestion. I'll talk about that toward the end. But those are for providers that don't necessarily have an API but still have their data available. And so here are some examples of like what that process looks like. So we have Airflow that manages this on a schedule. And you can see we have a varying number of records that come out of different providers. Some providers are producing hundreds of thousands of records by the time that we get back to them, or others we're loading, we'll say day by day. And like for instance, Wikimedia Commons, this was a run from July of last year that took 25 minutes and had some varying number. But the difference with the bottom right is here we have a single run from a data source called iNaturalist that ingested 15 million records. And so that was our first attempt at adding that provider. And the time that took was, you could see it said no data, but that's not because it didn't take any time at all. That's because it took too long. And so we ended up taking a different approach with that particular provider. So great, we have data in the catalog, right? But nothing new is being served by our API. And so here's where that bespoke data refresh server comes in. And so this happens with a broadly two-step process of getting new data from the catalog into the API. The first step is copying all of that data. So as it stands right now, that's exactly what happens. We create a new table with the same definition as one in the catalog. We copy all of the records from the catalog, and then we swap the tables in production. And then step 2 is updating the indices in Elasticsearch. Similarly, we just create a new index, insert all of the records from the API into that index, and then swap those indices in production. With a little bit more granularity, and I have the image sort of as reference in the bottom right, we also get popularity information from different providers. And that popularity information takes different forms. So Flickr might have like download count, whereas there are other providers that might have like number of comments, right, is the metric that we have available to use as popularity. And so as you might imagine, one of the greatest challenges that Openverse has in terms of ingesting this data is like the heterogeneous nature of all of these providers. And so we have a step at the very beginning which normalizes that popularity information across providers so that we can use the normalized form when we're running queries against Elasticsearch. So that's the first step, and that happens on the catalog. Second step is copy the table definition. I mentioned that. And then the third step is we copy all of the data from database to database. And then step 4, and I noted this in step 2, inserting records with indices in Postgres, particularly at scale, is not efficient because every time a record is inserted, it has to update all the indices. So it's much more efficient to copy the table with no indices, move all of the data over, and then apply the indices after the fact. So that's step 4. And then once the indices are applied, we index all the data into Elasticsearch, and then swap the tables into production. And so we also have Slack updates for when this process is occurring. Ideally, we run this currently at a weekly basis. And so we have data that's coming into the catalog constantly, and then once a week we do this data refresh process to get new data into the API. So here's what it looks like for audio. This was a particularly red letter day for us because the change that we got to audio was 600,000 new records up from 170,000. So it was like a 350% increase in the available production data, which was really stellar. So there are some advantages and disadvantages to this. The advantages, in one sense, are that we have clear separation of like what's production data and what's data that we can sort of mess around with, right? There's also a time delay between when we ingest records from a provider and when we actually serve them on the API. And this delay can be used and has been used by us to correct issues with the source data before they actually make it to production. And additionally, because the step at the very, very end is just swapping tables in Postgres and then swapping index aliases for which index to use in Elasticsearch. And for those unfamiliar with Elasticsearch, an index is very similar to like a table, right, one might think of. So we're just swapping tables to use and swapping indices to use. There's very little impact on production. And so the writes that are occurring constantly to the catalog database don't impact production whatsoever. Now, there's obviously also drawbacks to this approach, right? I said that we're running this on a weekly basis, which means that if we get data in right after a data refresh is run, then that data won't make it to production until a week later. And that's if the data refresh is immediate, right? For audio, it's quite quick, but for our image data refresh, it's quite a slow process at this point. This approach also requires maintenance of 2 distinct databases. And then lastly, we have this bespoke data refresh server, which is performing some actions, but those actions are being dictated primarily by Airflow. And so we have a desire to extract those pieces into Airflow entirely so that we can move away from having to also maintain this bespoke data refresh server. So next, I'm going to get into reimagining what this setup might look like, right? A lot of our time has been spent spinning back up these providers, getting in touch with the institutions to get like API keys, and generally getting things back up and running from the handover from Creative Commons. But now that we have that, we're in a space where we can start to rethink what this data story looks like, especially as we continue to increase the number of, there's no shortage of new Creative Commons works that are being added to the internet at any given time. And so we definitely have to be thinking of, OK, now we've reached this point where we have 700 million records. How do we continue to support this going forward? So one thing I mentioned with iNaturalist specifically is iNaturalist has an API, and we use that API to sort of crawl over their records. But that process was quite slow. They also provide bulk information about their data. So they have like the schema that's listed on GitHub, And then they have tarballs that can be downloaded with the actual contents of these various tables from S3. And so one thing we worked on was moving from this REST API interactive model to inserting the data that they have directly into the database and then performing whatever transformations we need to do to get from their data to the normalized form that we have on the database itself. And so you had seen from the previous screen that like the different providers that we have, total range of counts that we get, some are like 100 per iteration, other providers like around on the order of 1 million per iteration, whereas with this different approach where we're just doing the ETL within the database and not like trying to interact with a REST API, we were able to get 150 million new records on a single iteration. Additionally, in terms of thinking about how we might rework this stuff, this standardized popularity step is currently a bottleneck for moving data from the catalog to the API. So that's a step that no data can be accessed until all of the standardized popularity for all of the data has been recalculated for the entire data set. And right now, that's causing us some difficulties because of how much of a bottleneck that is. For instance, this is a graph of like the final row count in our API database versus the time it took to run that standardized popularity calculation. And so as we started off, I don't have like time here, but you can imagine that we're just generally increasing the number of records that we have in the API over time. And so we were doing like pretty consistently 15, 16 hours. And then we ingested a bunch of new records from my naturalist, and all of a sudden that process time shot up to 62 hours. And this is live data as of yesterday. We have now reached, I think, 700. So that's at 726-ish million records. We're now at 750 million records, and the current process time died after 21 days of running this calculation. That should say 750 million records. So obviously this is untenable, right? Because it now means that we're in a position where we can't update our API database without running this. And so in terms of plans for the future, one of the first plans that we have, one of the things that we're working on right now is decoupling that popularity calculation, because we shouldn't need to have like super accurate popularity data in order to get new data into the API, right? That's a benefit for search relevancy, but it shouldn't necessarily inhibit us surfacing that data in searches. Additionally, we want to add mechanisms to propagate information from the API back to the catalog. So the catalog is just constantly consuming information from the API, or from the various provider APIs, but there are cases where an image is deleted from those providers, or some link no longer works, right? And that, we don't crawl over all of the data that we have yet, but that information might be surfaced as someone is using the API, and they make a search, and we have a sort of precursor to the search that checks to make sure that all of those links are still live before we serve them. And so that information currently only exists in the API, and that's sort of information that we'd like to bring back to the catalog to know which records are still exist, right? Duplicate image detection, right? Somebody might have a creative work that they've uploaded to several different institutions, or several different social media sites, for instance. And so only retaining one record of that is something we'd like to achieve. And then further data normalization across providers. Things have changed since the project had started in 2016. And the data that we found has been important, or like different pieces of the data that we found have been useful, has changed. And so one of our recent projects was to build out consistency across those providers in the way that we ingest the providers, because previously it was like all of the business logic for each provider was repeated in each provider script. And so now we have like a unified interface for, okay, so you want to add a new provider. You only have to fill out these functions that are specific for the provider. All of the mechanisms around interacting with a REST API are abstracted. And then just like these are project ideas that we have up on GitHub. But more broadly, like our thoughts going forward are as I had mentioned, remove the bespoke data refresh server and move more of those operations into Airflow. I had described how we copy all of the records from the from the catalog to the API database. Probably don't need to be doing that. We can probably switch from a copy all into like an update, right, where we're only copying the records that have been updated since the most recent run. And then lastly, switching from ETL to ELT, meaning we currently interact with these providers, we pull data, we transform it into the form that our database is familiar with, and then we insert it, right? And that initial form is not something that we retain from the various providers. But what we have found is, frequently we, or occasionally rather, we want to add a new field or add some new piece of metadata about these properties, like image dimensions was one, right? Where that might be useful for folks on the front end as they're trying to search for images. If we wanted to reprocess, or if we wanted to gather that data, we would have to reprocess all the data from the upstream API. Whereas if we were retaining the results that we got from the upstream as we were interacting with the upstream API, then even if we did transform it into the step that we needed, or the form that we needed for the catalog database, we could still have that data to go back to. So all that to say, my question to you all is something to think about, is knowing if we're thinking about the black box of data comes in and data goes out, right? Knowing the inputs being ingestion and the outputs being search and API capabilities. If you were to start the Openverse project from scratch, how would you design the bits in the middle? And note that there are constraints to that question, right? We have massive amounts of metadata that we're working with that's very heterogeneous. We have media records that are going to be updated, so there's not just one insert that's happening. Those records might be updated over time. And then lastly, media records might be removed, or they could be also reported for any number of potential reasons on our front end. So the good news here is that we're an open source project. And so we have a strong community, and there are numerous ways to get involved into this project. We have a blog up on wordpress.org. It's make.wordpress.org/openverse. And then we also have like a Slack channel within the Make WordPress space. And we hold weekly community meetings every Tuesday at 1500 UTC. And that's in Slack, not like on Zoom or whatnot. And it's all asynchronous over text. And so if you're interested, it's very easy to stop by to one of those chats because it's just in Slack. And that time, 1500 UTC, depending on daylight savings time, is 7 a.m. for me. And so I take that in my PJs a lot. As I mentioned, all of our code is open source. We recently moved from several different repos into a mono repo. So almost our entire stack here is in this repository, which is really cool. The only thing that's missing, I have an asterisk here, the only thing that's missing is our infrastructure definition, which is in a separate repository. We have a really long contributing guide that details all of the various ways to contribute, both code and non-code ways to contribute to this project. We have a lot of people who have contributed just to the DX experience, to the design work of the project. Translations are also a big piece. We're part of the WordPress ecosystem in that sense, and so there's a lot of ways to easily contribute translations based on your language you're comfortable with. And then I had talked a lot about providers. Some of you might be thinking like, okay, well I have, I know a provider that I know some, we'll say some museum that has an API that serves Creative Commons or public domain images. Or if you want to help Openverse by adding a provider, we also have a number of existing providers that we as maintainers don't have the capacity to write ingestion scripts for. And so there's quite a few of those. And I had mentioned this a bit earlier, but we have, I would like to think, pretty thorough documentation on what it takes to add a new provider. And we have scripts that will set everything up for you. And all you have to do if you're adding a provider is fill in the bits that are specific to the transformation from that provider's REST results into the form that is needed for Openverse. And in fact, that's exactly what happened with iNaturalist. So the iNaturalist ingester, which was one of the bulk data ingesters too, that was all drafted and primarily developed by someone from the community who was not a sponsored maintainer. And this was someone who was using open source to learn how to do Python. And so it was really encouraging to see what they had created and have that be such a significant contribution to Openverse. Another benefit about being open source and something that we're putting more emphasis on as a project is doing our project planning out in the open. And so we've recently started doing this as of 2013, and on our documentation site, which is docs.openverse.org, we have all of the different projects that have been proposed and that are being worked on here. And so this was an example that's a project that I'm leading that has recently started, but then also, again, hot off the presses, one of my fellow collaborators has been putting out plans for doing that decoupling of the popularity calculation. And so if you have thoughts, the reason I bring this up is you can participate. We would love to hear your thoughts and your contributions on GitHub, where all of this work is happening publicly. Okay, that's all I have. Thank you for attending, and I'm open for questions if you have any.
Are there any questions? All right, I've got a question over here, and then I'll just be mindful of the time because they're back-to-back sessions. But go ahead.
As part of the reimagining exercise, have you considered either using PG, the Postgres vector search plugin, or even using an open source vector database rather than Elasticsearch?
So when you say, you're saying as a replacement for or Elasticsearch?
Yeah.
We have not. I have not personally. So can you elaborate on what these alternates are?
So I'm not a data engineer. I'm a data scientist by training, but I've recently just read a little bit more about how Postgres has a new search plugin that works pretty well, and you get rid of that additional layer of using Elasticsearch. And of course, then if you use search plugins, then another sort of counterpart that we can consider is using vector databases. Mm-hmm. But all of this is rests upon assumption that maybe we are doing similarity search based on the vector embeddings, but that may not be the case for you.
Yeah, so Openverse right now, our search is, I have to be honest, this conference has been super helpful for me because I've had opportunities to interact with people who are much better at search relevancy than I am. And so it's definitely, Openverse does some pretty naive things with regards to search, but the vectorized embeddings are something that I'm particularly intrigued by, and I think are something that could significantly help our result relevancy. And so I know that Elasticsearch has recently added support for that. A lot of the folks that I've talked about have said that it was recently added, and so it's still kind of a new space. But I'll take that into account as we start thinking about how do we vectorize these results to give, or vectorize these records to give better results. Yeah, result relevancy. I had push this back. Yeah, search relevancy is a big question for us in terms of how do we, as a team of maintainers who don't have any search experts among us, how do we take steps towards building more relevant results? Yeah. Thank you.
Thank you. Really great talk. My question is related to the data sources. So right now, as I'm seeing, the data integration is heavily reliant on a manual API script ingestion with certain providers. Mm-hmm. Is it at all feasible, or do you think it's possible somewhere in the future to integrate it with sources without in a more generalized fashion, without having to work with certain providers by the way we scrape web data, just to take in some website and looking for the data with in public domains or
Totally. Yeah, that's a really good question, and that was actually part of the history of Openverse actually, when it was creative search. So there was a process that existed for ingesting common crawl data, and using that to determine or to find images in a way that didn't involve REST APIs. That infrastructure was expensive and was not something that we had the capacity at the time to set up and restart, essentially. So that idea is out there, and it's actually baked into some of the history of the project, but it's not something that we're doing right now.
I've got another question.
Speaking of expenses, how do you get funding for the computation and the storage and the serving, and how does price factor into the decisions that you make? For a company, it's kind of clear you get revenue for building something and deploying it, but in a project like this, you need to make trade-offs for cost and computation.
Yeah, that's a good question. We are pretty much entirely sponsored and supported by Automatic as part of that Five for the Future effort. That effort also includes lots of sponsorship towards WordPress.org and a lot of the work, the dev work, the hosting that goes into WordPress.org, like as a project. And so costs are definitely on our mind, right? Like if I could wave a wand, we would have a much larger team with a much varied expertise for different aspects. There was a lot of learning that we had to do as a team on the infrastructure side. There's more learning that we're doing right now on the search relevancy side, right? And so that factors in a lot to our constraints. Is just like who do we have access to? What brain trust, right? Can we tap into, be it like the community or other folks that we know for sort of accomplishing this? And certainly, cost is definitely a big factor on the infrastructure side, right? You'll notice that we're using a lot of open source tools as part of the back end for this, and that's intentional because we're just constrained in that way. And so we're fortunate that the open source space, which we're also a part of, is like really rich, and we can build tooling off of that. But that to say, it's very hard for us to like. We haven't gotten to the point where we need to like make a big purchase or anything, and it will be a long process to do that, I imagine. Yeah. Does that answer your question? Okay.
How do you like? You said it was expensive to start up this other service. Like, I guess is the primary cost labor or compute? Sounds like.
In this case, probably both. But certainly, like one of our biggest constraints right now is labor. Like there's so much that we want to do on the project, and there's only 8 of us who are running the search engine, right? And so, certainly like labor itself is probably one of the bigger constraints that we have. Yeah.
How many?
And expertise, right? By way of labor, right? Particularly with like the common crawl, there was like much of that's done or was done with Spark, right? And like none of our team has expertise with Spark as well. So that has effects too.
How frequent are people searching Openverse? How many users a day is it?
Oh, it's a great question.
How many users a day does your small, understaffed team support? Is probably a better question.
I don't have metrics off the top of my head, but I think it's like hundreds of thousands of requests per day, on the order of.
Awesome.
We don't do a whole lot of like user tracking.
Mm-hmm. Good for you.
Yeah, and so we're trying to. In fact, like we've started doing user tracking, or we've started doing user analytics, right? But that has been a long process because we wanted to be particularly intentional about caring for user data because this is like a free open source tool. And so that has been a longer project and a broader conversation that has also occurred in the context of WordPress because the WordPress community, WordPress.org community is also similarly wants to be cognizant of like what data people are collecting. So, yeah.
All right, we are at time, so let's give Madison a big round of applause. This was wonderful.